Let's talk about some essential concepts which are crucial to understand before start building your own REST APIs. We're going to understand what is REST and what are RESTful design principles. REST stands for Representational State Transfer, is an architectural style for building APIs using HTTP protocol. Each URL represents a resource like users, posts, or orders or products, and HTTP methods define the actions on those resources, such as reading resource, updating resource, creating resource, and so on. There are several core principles, which is the default state, default behavior of the REST. Statelessness. No session state stored on the server. So every request is independent from the previous request, and the server does not have any information about the user or about the previous request of the user, unless we send specific token in every request to identify who is the user making request. Client-server separation. Backend and frontend are independent. So that's the crucial part of REST API. Backend is an independent API, and frontend can be anything. It can be a mobile application client, it can be a web application, it can be Android TV application, anything basically that can send requests into the API can be client of that API, and they can be absolutely independent. All right, uniform interface. There is consistent, predictable endpoints. All endpoints are named, all resources are named in a plural form, and that gives you ability to have this consistent and predictable endpoints for new resources. Responses define caching rules. There's a layered system in case of REST API. It supports load balancers and proxies as well, and everything is basically resource-based. We are going to focus on nouns, not verbs, and we're going to have nouns in plural forms. Let's see an example. Resources and endpoints. So, correct API endpoints will be API/users, API/posts, not API/get users or API/create post. If we want to get a specific resource, we still use plural form, API/users/1, API/post/22. If we want to get the nested relationships, such as all posts for the user 1, we still use the same approach, API/users/1/posts. So that's the basic rule of resources and API endpoints in REST. Now, let's talk about HTTP methods. There are 5 core HTTP methods. There are a few more. Totally, I think there are 7, but these 5 are the core HTTP methods. Get, which is for reading the information. Post, which is for creating the information. Put, for updating the information. Patch, also for updating the information. And delete, for deleting the information. Here's an example. We are reading all posts, a list of posts, or we are reading a specific post with get method. We are creating a post with post method. We are updating a post with the put method or patch method. And we are deleting the post using delete method. The difference between put and patch is that typically when we make requests using put method, we replace the entire resource with the new one we send. So we update it, yes, but we replace. Let's say the resource has 10 properties, so we send only 7. The other 3 will be like a lost or null values will be written inside. However, when we send patch requests, we can only send one property if we want to update only one property, and that one property will be updated. So that's the idea of patch. All right, now let's talk about some consistent naming conventions. So when we have REST API resources, and if those resources especially are combined of like multiple words, let's say country products. So we use the following naming: all will be in a lowercase. And we're going to use snake case or kebab case approach. Lowercase, snake case, or kebab case. All right. So as I mentioned, if we have like country products, that will be country underscore products or country dash products. That should be the proper resource name in the URL. All right. So we talked about that we're going to avoid verbs in the URLs, and this is the correct, this is incorrect. We're going to have everything in a plural form. All right. Now, let's talk about some important HTTP status codes, because understanding status codes is crucial for building the REST APIs, but also building a client, whether that's going to be a mobile application or web application that uses the REST API, because you should understand what each status code means when the REST API returns them. We have three main groups of status codes in REST API: 200 status codes, 400 status codes, and 500 status codes. Okay, so 200 means success. If we get 200 okay, that means that our request successfully completed. 201 typically means that the request successfully completed and a new record was created in the database. And 204 means that the request has been successfully completed and nothing is necessary to be returned. Inside 400 status codes, we have a little bit of more options, like 400 means bad request, user sent some invalid input. 401 is unauthorized, user was not properly authorized and probably missing expired token, something like this. Forbidden means that user doesn't have permission to perform that specific action. Let's say the user is trying to delete somebody else's post, right? So that's going to be forbidden. User, like when user is trying to delete a non-existing post, we're going to get the not found error, and this 422 typically means that the validation was failed. We also have 429, which means that we are sending too many requests in a short period of time, and there are a couple of more. In case of 500 server error codes, we have 500, which is the main error code, which means something unexpected happened on the server, but we also have 502, 503, and a couple of others. All right, so all of them typically means that there is some issue on the server, not in the client. When you get something related to 400, you should know that the issue is on your side, so you're doing something incorrect. But in case of 500, the server has some issue. All right. So now let's talk about request and response format. So we use typically JSON to exchange data recently. Previously we had XML, but I'm not going to talk about XML right now. JSON stands for JavaScript Serialized Object Notation, and it looks like this. So if this is the first time you're coming across to JSON, this is how it looks like. We have curly braces. Inside curly braces, we have some key, and then we have colon, and then we have the corresponding value of that key. As an example, in this case, we have data, then colon, and then the following object corresponds to the data. Inside that object, we have ID, colon, and then 1 corresponds to ID. We have name, and 0 corresponds to name, and we have email as well. All right, so this is going to be the typical request, what we're going to send when we want to just update one specific user. Let's say we want to change the name. So we're going to provide new name here and send something like this. In case of error responses, we're going to also expect to receive JSON, and this is one example how you might receive the following response, that this like we have the field name and we have the message, but this is just one example. So in our Laravel application, we might receive error responses in a different format. All right, so here are a couple of best practices which I want you to pay attention. We're going to never return HTML or plain text. We're going to always try to include helpful error messages. We're going to use camel case or snake case consistently. We are not going to mix them. Snake case, as I mentioned, when we use underscore, this is the snake case example. Camel case is when every first letter of a next word is uppercase, like C in this case, and the first letter is always lowercase. And in case of pagination, we're going to always provide some additional helpful metadata. All right, now let's talk about versioning, because versioning is crucial when building REST APIs if you plan to scale your API. Why? Because when you just release your API initially the first time, you have something different and people start using that, and after 1 year you decided to change something and you made so crucial changes that those people's API usages were completely crashed. So the clients which we are using your API and you made some important changes, some crucial changes, which changed the response as an example, or request structure, how you accept the data or how you return the data, those clients were crashed. Okay, they are not working anymore. That's why if you decide to make such big changes in your API, it's important to release a new version. In this case, we have API/version1 users. Let's say this is the one you initially released, and after 1 year, you made a very big and important changes, for which you just simply created new API endpoint. And let's say you gave your users like 6 months notice. Hey, we now released new version of the users resource, and please start using that, because after 6 months we're going to drop the version 1 users resource and it's going to be completely gone. If you want, so you can do this as well if you think like the version 1 should not be supported anymore. All right. And the whole idea is that we're going to support multiple versions at the same time during this transition period. We deprecate old versions and then we simply remove them. Awesome. Now let's talk about what is statelessness. So we have self-contained requests, which means that every request is isolated. It doesn't have anything common with the previous request, and we send the whole information, what we need the server to know in this specific request. Okay? No server-side sessions, we don't have sessions, which means that no information about the user is saved on the server side, and the only information that can identify who is the user is transferred inside the request itself, like a JW token as an example. Benefits is the scalability. Any server can handle any request, and that's a very, very good thing. Simplicity, we don't need session management, and that makes it very simple. The scalability part is also an example when we have multiple clients, like we have, because we don't have sessions, we don't have anything like this. We can use, we can create mobile application using the same API. We can use web application. We can create web application with the same API, and so on. We have caching as well. Responses are easier to be cached, and we have reliability as well because we don't have session state to lose. And because of this, we can create multiple clients out of the same API. That's also a great thing. Now, in case of pagination, filtering, and sorting, this is also supported in the RESTful API, and here we have typical examples. Let's say we want to get the posts from the second page, and per page we want only 10 items. This would be a typical example. Let's say we want to sort the items, sort the posts by the created at in descending order, meaning the latest created post should be at the top of the list. This is how we typically would do this. We would be able to make the request on the following URL. And in case of filtering, we can also specify we want to filter the post with the author ID equals 3 and status to be published. Okay, that's also a really great thing. And finally, we are going to stay consistent and we're going to preserve some standards. All right, so resource name should be in plural form, as I mentioned, that's the one thing. And based on the framework you're using to build REST APIs, you should follow that framework standards. We're going to maintain these predictable patterns, again, plural nouns. In case of our REST API, we're going to use Laravel, and we're going to leverage Laravel features. We're going to use resource controllers and API resource classes to follow these standards, which is going to be a great thing, believe me. And we in some cases, and in our case as well, but in some cases in other frameworks as well, there are abilities to automatically generate RESTful API routes. And that's a great thing, because when the framework automatically generates those routes, like, they are going to be in a consistent way always. When you manually write something, you might make some typo there, or you might name it inconsistently a little bit, although you should try to be very consistent. But when automatically generate the routes, that's going to be always consistent. And Laravel's API resource also creates the standard routes automatically in the following way, and we're going to see this in action. All right. And the last example, a real world case example, would be using the following command: php artisan make controller post controller --API. That would create a controller with 5 methods inside. One method, index method, will be to list all the posts. Show method will be to get a specific post. Store method would be responsible to create a post. Update method to update the post, and destroy method to delete the post. And this would be the URL examples for each of them, for 5 of them. All right, now that's the theory. Now let's focus on the